Okay, I think we can move on to our next talk. It's going to be Alison Gopnik from Berkeley, who's going to tell us about evolution and LLMs.
Yeah. Okay, so what I'm going to do will follow very nicely, I think, on Les's talk, because I'm going to talk about a whole lot of work on what's called cultural evolution, which is actually work, including a lot of quantitative work that's been done on the idea that human beings are adapted to this cultural niche, that our great superpower is our ability to learn from other people over and accumulate that learning over time. And some people in the room have actually worked on this. And what I'm going to do is I'm going to take this basic idea about cultural evolution and what's been called the cultural niche, and I'm going to talk about it in two contexts. First of all, as a way of thinking about large models in particular, that's really different from the way we typically have thought about large models. And I'm going to argue that the right way to think about large models is as a cultural technology. It's part of this process of cultural evolution. And then in the second half of the talk, I'm going to talk about how we might solve some problems that are intrinsic to the idea of cultural evolution, and in particular about how human development and life history, the fact that we start out as children, become adults, and then become elders, you can think of as actually a solution to some of the problems of cultural evolution. And I'm going to suggest that we might want to take some cues from those solutions for artificial systems. Okay. So let me start with the idea of the cultural niche. This is probably the people who originated this idea and have done the most work on it are Richard Boyd and Peter Richardson over 30 years. But Joseph Henrich is probably the person who's popularized it. His book, The Secret of Our Success, is a good place to start. And the idea is that the reason why human beings are so successful, so intelligent, is because we have the capacity to learn from previous generations of human beings. That our great superpower is that we can, over many, many generations, take information, pass it on to a new generation, modify it in the light of new information about the environment, change what we do for the next generation, and so forth. So that's the idea that we have this cultural niche. And although I'm sure Lucy and Amanda would say you have signs of this in other animals, I think everyone would agree that we do this much more than any other animal, including our closest primate relatives. And the part of the point that Joe and Dick and others have made is that all these things that we think of as being characteristically human, like our ability to use tools and our ability to do artistic work, our ability to use language, those are all the result of these capacities for cultural evolution, rather than some sort of more basic, rather than other kinds of intelligence. And a really interesting point that I want to make about this, particularly in the AI context, is that the cultural niche really seems to be adapted to the non-stationary environment. So both in terms of its causes and its consequences. So when you actually look at why is it that our closest primate relatives are not doing this and we are, there's I think a fairly consensual argument in the physical anthropology world that the thing that happened out in the world that led us to start using culture was that the environment became much less predictable, and it became much less predictable over the space of a human lifetime. So what happened, my line about this is nowadays humans are causing climate change, but in the past climate change caused humans, so that you actually had this much greater variability, much less predictable climate. And when humans moved from the forest to the veldt, that just increased this variability. And then, of course, if the solution to that variability, that non-stationary environment, is to have culture so that you can change what you're doing, you can learn how other people have dealt with particular environments, that itself leads to more variability, because each generation is going to have different kinds of strategies for dealing with the particular environment that it finds itself in. And what that means is that now if you're growing up, you're going to have to deal with the environment that's been shaped by those cultural tools. So the idea is that for humans, our ecological niche is the non-stationary environment. That's what we're all about. And you could think about culture as a solution to these non-stationary environment kinds of problems. And of course, that's still a great problem for current AI systems. Okay, what does this have to do with LLMs? Well, there's a sort of intuitive theory that people have of AI and large models, including like really sophisticated, rather surprisingly, including really sophisticated people in computer science. And this view is what I'll call the intelligent agent view. So the idea is that the right way to think about artificial systems, and in particular large models, is that they're agents the same way that humans are agents, for example. And then the question becomes, are they good agents or are they bad agents? So you could either think of them as being beneficent superintelligences, or else you could think of them as being golems. And it's an interesting side note that the golem, the Rabbi of Prague story about what happens when you have an artificial system that comes to life, is actually pre-industrial, and it's part of a whole genre in pre-industrial Europe of stories exactly like this. Something artificial actually comes to life, and it never ends well. The stories always end badly. So there really seems to be this kind of deep human meme about if you actually had something that was artificial but could do some of the things that humans would do, it would be powerful and it would be bad. This kind of view of the intelligent agent goes along with a view about intelligence, which also seems to be this very sticky, intuitive version, which is also wrong. And that's the view that you should think about intelligence as being a kind of semi-mystical substance that you can have a little bit of or a lot of, and your competence depends on how much of this substance you have. So if you have a little bit of it, you're going to be able to be a little intelligent, and as you get more and more of it, you're going to be able to do more and more, and you're going to be more and more powerful, for example. And I think, again, this is interestingly analogous to things like intuitive theories of life that you will also see in children and in many different kinds of cultures, where if you think about something like chi or the life force or the Marin County energy term, right? Those are all ideas that what makes something alive is this force. And if you have a lot of it, then you're going to be healthy and energetic. And if you don't have a lot of it, then you're going to be weak and you're not going to have a lot of life. And of course, we know that that's just not true. That's not the right description. And I think cognitive science has told us that this description of intelligence is something you have a little of or a lot of, and you could have more of, just isn't the right description of how intelligence works. And in particular, although there could be artificial systems that are in fact agents, it's a very bad way of describing the large models that people have been interested in most recently. So what's an alternative? An alternative is, go back to this cultural niche, is to think about these large models as the latest development in a long human history of what I've called cultural technologies. So arguably, the thing that has made the most difference to human thriving culture society are not just the technologies that let us go out and do things, but these technologies themselves actually shape the process of cultural transmission. So the more information you can get from more people across more time and more space, and the more efficiently you can access that information, the more you're going to be able to take advantage of the cultural niche. And you could argue that language itself is the kind of example of a cultural technology. Again, the thing that makes us different from other primates is the fact that we have this basic system that lets us extract information from the other people around us. As you'll see in the second half of the talk, I think the really crucial piece of this is the postmenopausal grandmothers. So the way to think of this is, once you have language, then you can listen to what your granny says. You can learn from what your granny says, which means that you've got 100 years worth of cultural knowledge. What happens is that you then develop all these different kinds of technologies that all have the effect of giving you a wider range of information, making the information more compressible, making it more accessible. And I want to, particularly in this context, especially given the workshop that we had a few weeks ago, it's talk about something that was not actually in my original slide about this, which is pictures. So actually, it seems like from the archaeological record, the next thing after language is pictures. It's actually using depictions as a way of passing on cultural information from one group of people to another. And writing, which is the one that I had originally talked about, is really derivative from this idea of pictures. And the reason why I want to make this point is because when people talk about the vision models or the multimodal models, they often talk about it as if it was like vision, right? So in the case of vision, you've got a bunch of data from retinal patterns, and then you're inferring something about the world. And people often have this kind of illusion of, oh, these are vision models with data, as if it was like the data that you have in your normal vision. But what these are picture models. So what these are models that have taken text, right, at least the large models, and in addition to actually having this cultural information that comes from text, they also have cultural information that comes from pictures. And an Apple camera shot on Instagram is just as much a picture as a Lascaux cave description of an animal is a picture. It's something that a human being has designed to try to communicate information to other human beings. It's not at all like the information at your retina that lets you actually do vision. When you get to writing, you can learn from even more grams over a wider space of time and a wider space of space. And we have lots of reason to believe that writing actually has transformative effects on both cognitive and social capacities. Print is one of the ones that I've been particularly interested in. You get print with Gutenberg, but then you get these big changes. I'll talk about them a little bit later on at the end of the 18th century in print technologies, which meant that not only could you print something, but you could distribute it very rapidly and very effectively. And I'm going to use that later as an example of something that completely changed, again, both our cognitive and our social capacities. And this is not just about actually being able to have media for information, but I think just as much it's about being able to compress and access information. So if you even think about the difference between language and just the information that language encodes, it gives you this very compressed, efficient code for information. And when you talk about writing, that takes that linguistic code and it gives you an even more compressed and efficient piece of way of thinking about it. And if you think about print, print gives you the information. Libraries actually give you a way of accessing information. So libraries, I like the idea that the beautiful wooden card catalogs that were such a fantastic artifact of our youth were actually like the equivalent of LLMs. That's the thing that was the equivalent of LLMs. And a human with a card catalog and a library can generate text, can answer questions, can do all the things that an LLM does in a way that just a human with a human brain cannot. And then, of course, once you get digitization, you get things like internet search. Once you get the internet, then you can have internet search and things like Wikipedia that give you an even better way of accessing that information. And parenthetically, I think the big change is not AI. The big change is around 2000 when, sort of unheralded, all the information in the world became digital. So you get HDTV, you get PDFs, you get digital movies, and suddenly all of the information is now accessible to you through a digital means, which of course means infinitely reproducible and accessible instantaneously in time and space. And I think that's actually the thing that makes the big difference. And the LLMs are just like a logical consequence of what happens once that starts. Okay, and this is a really different picture than that intelligent agent picture. But it's important to say that one of the things that the cultural transmission view gives you is that intelligence is about relationships between human beings and these cultural tools. So as I say, a human being with a library and a card catalog is a fundamentally different kind of creature than a human being who doesn't have those kinds of cultural tools. And it seems sort of absurd to say, well, okay, is that person who has the card catalog more intelligent or less intelligent than the person who doesn't have the card catalog? That's kind of a dumb way of thinking about it. The right way to think about it is when you have certain kinds of tools that allow you to access certain kinds of information, that gives you capacities that you wouldn't have had before. And I think the right way to think about large models is they're the latest example of a tool that lets human beings do things that they couldn't have done before. Yeah?
Sorry, so would it be right to say that here you're focusing on Yeah. Would it be right to say that here you're focusing on cataloging and retrieval of culture rather than creation of culture?
Yes, and I will get to that point in a minute. Yeah, exactly. So what I'm saying here is what I'm talking about is cultural transmission, getting information from one group to another. And exactly the point that I'll get to in the second half of the talk is that, of course, that depends on innovation. That depends on cultural creation, which is something that these systems are not doing. But let me first say something, particularly in the context of, particularly in the context of practical questions about what the consequences of these developments are going to be. That every time there's been, now this is not a debunking picture about LLMs. In fact, I don't know if there's the opposite of debunking, is kind of like a rebunking or a superbunking picture. Because the truth is that bringing more agents into the world, which is something that all of us are actually quite effective at doing as human beings, has less of an effect than introducing these new cultural technologies. So if you look at writing, this is a quote from Socrates, who famously thought that writing was a really bad idea. I won't go through the whole quote, although I really love it. But I really like that last sentence, right? Where they seem to talk to you as though they were intelligent. But if you ask them anything about what they say, they just go on telling you just the same thing forever, which sounds a lot like ChatGPT, right? That's Socrates saying you pick up the book and instead of interrogating the book, it just tells you this thing that sounds like it kind of might make sense or might not make sense. And Socrates points out that writing actually leads characteristically to hallucinations. Like if you go to the library, a tremendous number of the things that are in the library are going to not be true. And no one ever sort of says, oh my God, we have to really purge the library because the library is hallucinating all the time, right? That's just not the right, that's not the right category. But when you have cultural transmission, you face this problem about trying to independently assess the validity of what's happened. And Socrates pointed out this is going to be harder to do with writing because you're going to see something that's written down and you're going to think that it's true, even though you're not checking it against the external world. He also thought that you wouldn't memorize the works of Homer anymore. And he was right about that too. So he was right that writing had the effect of making people believe things because they were written down, and it had the effect of undermining memory capacities. Probably most of us would say that writing in the long run was a good idea, but I think the jury might still be out about that one. And then this example that I really like is the late 18th century print example. So there's these big technological changes in printing in the late 18th century. And this is actually Benjamin Franklin, who, of course, was a printer. Well, it's not a coincidence that Benjamin Franklin was a printer, because the capacities for printing were arguably responsible for the Enlightenment, for democracy, for the intellectual and social changes in the late 18th century. So the fact that, Tom Paine's Common Sense or Benjamin Franklin's Poor Richard's Almanac could immediately be distributed to many, many, many people at once was a major contributor to the changes in thought and the changes in social organization at about that period. There's a lovely example that I really like from the biography of Samuel Adams that just came out. I highly recommend this. So all of us know, or all of us Americans know about the Boston Massacre, right? So the Boston Massacre was this thing that started the American Revolution, and a bunch of terrible British soldiers came and they killed a bunch of innocent Americans, and then that caused a lot of indignation and led to the revolution. Well, it turns out that here's what actually happened. There was a weird, complicated, ambiguous event of the sort that happens when you have a bunch of teenagers together with a bunch of guns, which is essentially what happened. There were a bunch of teenage boys around. There were a bunch of teenage British soldiers around. Somebody let off a gun at some point. Somebody threw a rock, and then a bunch of bad stuff happened. But Sam Adams, who was a printer, literally that night went to the press, and it's great. He actually got Paul Revere to do pictures for this. So he set up a story and he got Paul Revere to do pictures. And of course, the pictures were the terrible British soldiers massacring the innocent Americans. And then that became the Boston Massacre, and that was the story of the Boston Massacre that led to the American Revolution. So even though Sam Adams is kind of a hero, like he was really a master of misinformation and memes. So the American Revolution sort of starts with misinformation. And even though we think about these examples as being even if they might be a little dubious, as being positive, there's this marvelous book, A Reason for Getting Humanities Scholars and Historians into Thinking About AI by Robert Darnton, where he actually went and looked at all the pamphlets that were being produced in France in the late 18th century. So everyone had thought about, common sense and the good, interesting pamphlets. But what he did was read the whole thing. And you will be amazed to discover that most of it was softcore porn and libel. So that was like, anytime you get a new cultural technology, the first thing notoriously that anyone uses it for is pornography. And many of the things, again, in the French Revolution, many of the things that brought about the French Revolution came out of this literary underground. So Marie Antoinette saying, "Let them eat cake," was actually, again, an invented meme that spread very quickly and that people were willing to believe because it was there in print. As far as we could tell, it never actually happened. So the general picture is that these changes in cultural technology have the capacity to really change people's knowledge, their intelligence, their social structure, again, for good and for ill. And it's interesting that the for ill kind of seems to, both the for good and the for ill seems to sort of take the same form across many different cultural technologies. And of course, this will be familiar as you're thinking about large models now. There's another interesting thing, though, about it, which is that, so you might ask, well, why do people feel as if the AIs are agents, right? Even to the point of referring to them as the AIs rather than referring to them as an AI or a large language model. And I think it's really interesting that if you look at the history of cultural technologies, a very common way to pass on cultural information is through fictional agents. So we're really good at dealing with agents. And very often the way that you pass on information that's important is by telling a story. So when Grandma says to her 3-year-old, as I recently did, look, here's how norms and rules work, and you really shouldn't violate norms and rules because there'll be bad consequences. Grandma says, Peter Rabbit went into Mr. McGregor's garden, even though he wasn't supposed to. And then the result was that he had chamomile tea for dinner instead of bread and milk and blackberries. Why does telling a story, an obviously false story about what a rabbit does, acts as a means of trying to pass on these big picture ideas about what's important in the culture? And there's lots of beautiful anthropological work by people like Polly Wiesner that this is in fact what happens with fires. So if you look at the content of conversation in a forager group over the course of the day, mostly during the day, what you have is the adults talking to one another, and mostly what she calls CCC, which is criticism and complaint. Mostly what they do during the day is complain about how everybody else is not doing the things that they're supposed to be doing. But at night, what happens is the conversation shifts, and now instead of the adults being in charge, it's the elders, the grandmothers, and the kids who are engaged, and the grandmothers are telling stories about the big important things about the culture to the kids. And I think if you think about things like gods, they're another example of the way that we use fictional agents to actually pass on cultural information. So as I say, don't say that I said that LLMs are gods, or at least say LLMs are gods only in the same way that all gods are gods, which is that they don't exist. The idea is that if you have something like a god's a way of carrying on information about the difference between, eros and intellect, or all the other kinds of information that you might want to convey. And again, this is an example that I can't resist as the daughter of an English professor. So when you get these changes in print technology in the 18th century, one of the things that happens is you get this new literary form, which is incredibly popular, which everybody reads, especially adolescent girls. Adolescent girls are always at the cutting edge of these changes in cultural technology, and everyone's always sure that it's a really, really, really bad idea that they're adopting the new cultural technology and it's going to lead to the death of civilization and rewiring their brains for anxiety or whatever it is. It's somehow always the teenage girls who are the focus of this. So what were the teenage girls doing in the 18th century? They were starting to read novels. And I asked my father, the novel appears at just the same time these changes in print are appearing. This is Pamela, which is one of the very first novels by Samuel Richardson, who was essentially the first novelist. And it's interesting. It's got a little softcore porn kind of stuff going on, but it's got a lot of empowering young working class women in it too. My father is an expert in Samuel Richardson, and I asked him, do you think print might have influenced what Richardson was doing with starting the novel? And he said, well, you know what Richardson's job was? And I said, no. And he said, well, he was a printer. So it was actually literally true that he was printing these new forms that had these fictional agents that were carrying on new kinds of information. So I think part of the reason why it seems so natural to us to think about LLMs as if they were agents, to think about, ChatGPT as someone who you talk to or you ask things, is that that's been a very common way that for human beings to efficiently pass on information in this kind of cultural technology way. All right. So that's the first part, which is about trying to think about thinking about large models in particular. And again, a parenthesis is, I think there are kinds of artificial intelligence that really are more like an agent. So if you think about, a robotic system that's learning from reinforcement learning, that looks a lot more like what we think of as an intelligent agent. But I think the reason why large models are effective is not because of that, but because they're encapsulating this long history of cultural transmission and cultural information. Now, one thing that's a problem, this gets back to the earlier question, is that this cultural evolution depends on this balance between imitation and innovation. So there'd be no point in passing on information if at some point somebody didn't actually find out something that's new. So you could easily imagine, and in fact, there are cases of cultures getting stuck in a kind of local minimum where you're just passing on information from one generation to another, but you're not checking it against the world and you're not actually learning anything new. So in order for this cultural transmission to really work, you have to have this balance where on the one hand, there are people who are going out in those non-stationary environments and figuring them out. And on the other hand, other people are taking the discoveries that the people the innovators have made and then applying them themselves and passing them on to the next generation. And we know from many studies in developmental psychology that this is something that children are doing literally from the time they're born, and that they do it in a really sophisticated, interesting way. So there's a big literature on children learning from imitation, children learning from testimony. And I'll just give you one example from our lab, because I feel like, partly because as a developmental psychologist, I have a moral obligation to have cute kid videos. So this is a study that we did back 10 years ago now. And what we did was show children an artifact, the sort of thing that you might imagine you could learn through cultural transmission. So what happens is you squish this toy, you squeeze the bulb, you pull the ring, and the toy plays music. And what you can do is show different kinds of, but you could do another sequence of actions on this tool. You could pull the handle and squeeze the bulb and pull the ring and it will play music again. What you could do is show different kinds of patterns of sequences with different kinds of outcomes. So we can show the children these patterns of 3 actions, and then either the machine plays music or it doesn't play music. And what you can see is that if you're doing the kind of causal inference that I talked about in my first talk, in the first workshop, you should make different conclusions about the causal structure of this tool, and that should lead you to produce new actions on the tool. So if you see this pattern, right, where the first action is changing, but the second 2 actions aren't changing, then you should infer, oh, the causal sequence is that it's actually those second 2 actions that were responsible for the outcome. Whereas if you see this one, then you should infer that it was all three that were responsible for the actions. And we actually did a kind of Bayesian causal model to show that this was true, but you can sort of see it intuitively. And what we did was we gave 3-year-olds, here's a 3-year-old.
Yeah, I've never played with it before. No, it's so funny. If please.
Sorry. Shoot. One person. Anyway, what she's doing is showing this to the little boy, and she's saying, look, here's my toy. I've never seen it before. Let's see what happens if I do things to it. So then she says, let's see, what shall we try? And she produces the sequence of actions. So she says, let's squeeze it, and then we'll pull this ring, and then we'll pull the top, and look, music! You can see from his expression that the music played. And then she does a different sequence, and there isn't any music. So now she's trying a different sequence, and this time there's no music. And she does that 12 times. This is a 3-year-old, but the 3-year-old is quite happy to sit there and watch 12 examples of this. And then so what he does is actually infer the right causal structure. This is mini innovation, but it's still innovation. It's still something that he hasn't seen, that he's appropriately inferred about how to use this tool. And then the great, the reason I like producing this talk a lot in sort of, broad popular circles is we also did this. Notice that she, having been trained at MIT, was very good at being clueless. So she said, I don't know how this works. Then we had another condition in which what she said was actually, here's my toy, I'm going to show you how it works. If she does that, then the kids just imitate one of the sequences that she's produced. So if they think they're in a pedagogical setting, then they don't make the inference to innovation. They think, okay, this is a cue that I should just be doing imitation. And again, we looked at the sort of the rational basis for that. So what this means, and there's many, many other studies like this, is that the children in this very beautiful, fine-grained way are balancing information about the causal structure of the world and information about the causal structure of the mind of the person who's giving them information. And we've done some interesting things about this with macaques, and I can talk about later on. And they're combining those two things to actually give this more intelligent response than you would get from, say, behavior cloning in an AI system. Okay, and I think it's not a coincidence that you might be surprised that these very small children are doing this as effectively as they are. What I would want to argue is that, in fact, this is precisely the cognitive niche that children are fulfilling. So let me get back to one of my morals, is that there's no such thing as general intelligence, natural or artificial. And this is particularly true if you're thinking about the cultural niche. The cultural niche means that there's this very wide range of different kinds of competencies you could have in coordination with different kinds of cultural traditions, with different kinds of tools. And in particular, some of these cognitive capacities actually trade against each other. So they're actually in tension, in conflict with one another. And the great classic example of this that everyone in AI will be familiar with is the exploitation versus exploration trade-off. That the things you need to do to maximize your utilities are not the same, and in fact are often the opposite of the things you need to maximize your access to information about the world. So your epistemic motivations and utilitarian motivations are different. And as we'll see, there's another interesting piece of this, which is that there's also a contrast between this sort of exploitation, maximizing your utilities, which has typically been seen as being what intelligence is about getting around in the world and maximizing your utilities. And then this niche of taking care of the people who are exploring and actually transmitting cultural information. And what I want to argue is that our distinctive developmental life history, with a very long period of childhood, and then much longer than any other creature, and also this very long period of postmenopausal elderhood, also unique, not found in any other creature, is a way of dealing with these imitation innovation trade-offs across the space of life history. And this might have something to teach AI systems. And this is a part of a general issue of the philosophical transactions of the Royal Society, where we talked about this. So let me go through this fairly quickly. One thing that we know is that same chart that showed the climate variability. One of the distinctive things that happens is that you get a much longer childhood. So this chimp in the Gombe, by the time the chimp is 7, the chimp is producing as much food as he's consuming. And my youngest son is 35, and for humans, even at 35, we're writing tuition checks and rent checks. But certainly, even in forager cultures, you don't see you're not producing as much food as you're consuming until you're at least 15, until you're at least an adolescent. So that's a big change. And of course, it's striking because it's a really expensive change. I mean, literally expensive. It means a lot of you need a lot of energy and output to keep those babies going. And interestingly, it seems to be a very, very, very general principle of biological intelligence across many, many different creatures, including birds and many different kinds of mammals, and interestingly, even insects. I can talk about this. So across many, many different kinds of species, you see this relationship between the length of childhood and brain size, flexibility, learning, at least the kinds of intelligence that at least certain kinds of what we might think of as intelligence, especially this sort of flexibility and learning. And you see this in neuroscience as well. So you see this in brain development, where what you see is this early period of many, many new synaptic connections. This is boilerplate. Many new synaptic connections are being formed. And then there are these tipping points where what happens is that you get pruning. So the ones that have already been formed are strengthened and myelinated. And then the ones that haven't been formed are pruned and are left out. And essentially what that means is that you have an early brain that's really well designed for plasticity. It's very well designed for learning, for extracting information from the world. But there's this plasticity stability trade-off. I think all these sort of explore, exploit, imitation, innovation, plasticity stability are all sort of versions of the same trade-off, where you're not as good at acting early on, because acting is exactly about narrowing the range of considerations that you have and the range of information that you have. So my short version of this is that there's this fundamental exploitation versus exploration trade-off. And I'm assuming in this audience, I don't need to explain simulated annealing, which is something I usually need to explain. Let's see. Oh, is this not working? Yeah, there it is. And of course, in computer science, we solve this with various kinds of techniques like simulated annealing, where you start out with this high temperature explore, search through possibilities, and then cool off. And a little parenthesis for the theoreticians in the audience, everybody's going to be giving you guys jobs. One really interesting thing that I've discovered is that if you go out and you talk to the people in the new machine learning universe about this, they'll say, yeah, this is absolutely essential. This is all you have to have the right schedule. You have to have the right annealing schedule to make any of this work. And then when you say, and what's the principle? Like, is there this proof about, they say, well, basically you fiddle with the knobs. We're engineers. You fiddle with the knobs until it works. And then that's the way that you decide what the right schedule is. And I think there's a really interesting theoretical question about what you can say about what the right kind of developmental schedule would be for solving different kinds of tasks. So my hypothesis is that childhood is really evolution's way of performing simulated annealing. So you get this early protected period when you can do a lot of different things, when you can do this kind of high temperature search, and then you narrow in on the low temperature search later on. And from this perspective, many things which, and this gets back to the idea that there's no such thing as general intelligence, many things that are bugs from the exploit perspective are features from the explorer perspective, and vice versa. So the kinds of things that you see in a high temperature search, which is lots of noisiness, lots of variability, lots of randomness, taking risks, being impulsive, doing things that don't seem to make sense, engaging in play rather than actually engaging in any useful work. I mean, in a way, the definition of play is exactly when you're doing a whole lot of activities that are useless, right? That's and play is characteristically across animals is characteristic of the young rather than the old. So evolution seems to use this strategy of start out producing a wide range of noisy variable behavior and then narrow into the useful behavior later on. And you can see a kind of motivational structure too. So this kind of insatiable curiosity that you have with young kids that everyone recognizes is another example of this highly epistemic rather than utility-based motivation. And in fact, in my lab and in lots of other labs, even though usually when you do an experiment, because you're doing an experiment, older people are going to do better because they understand how the experiment works and they can pay attention and so forth better. There's a whole bunch of really interesting examples where actually younger learners are doing better. And they're all examples where the solution requires more exploration, where the solution's sort of unexpected, low probability, further out in the space than the more obvious solution. And in fact, there's a beautiful recent paper. I wish it was from my lab, but it's from Charlie Wu and Eric Schultz that actually has in Nature Human Behavior that demonstrates that these developmental changes look like stochastic optimization. Okay, so let me go to the third part of the talk. So that's the second part of the talk, is the argument that in order to solve this imitation innovation problem, one solution to that is to have children, and I think also adolescents, maybe adolescents even more than young children, who are using this random variable, high noisy exploration kind of way of being in the world. And that's a way of kicking you out of, another way of thinking about it is childhood is evolution's way of kicking us out of cultural local minima. So it's a way of having a next generation that can look at the non-stationary environment, right? Look at the new environment, which is not the one that grandma knew about, and say, okay, here's different ways that we could characterize this environment and different strategies that would work in this novel environment. But of course, that all depends on another kind of capacity, another kind of intelligence, which is the intelligence of care. And I love this experiment. I may have talked about it with some of you before. It's my favorite experiment in psychology, I think, relatively recent experiment. Here's what happens. So the oldest finding, boilerplate, first year psychology 101 is this. You put a rat in a maze, goes down one arm of the maze, it gets shocked, goes down the other arm of the maze, nothing happens. What will happen? The rat will not go down the arm where there was the shock, right? That's the most basic fundamental learning principle. That's the principle that's responsible for reinforcement learning. That is reinforcement learning. Except that there's a catch, right? Which is that if the rat never goes down that arm again, it's never going to find out that maybe it's a non-stationary environment. Maybe sometimes there's actually cheese at that end of the maze. And it's interesting that this is kind of like a model for anxiety disorders, is what happens when you get in the plane once and it's really miserable and there's turbulence, and then you never find out that actually you don't have to be scared because most of the time it's not like this. All right, so that's the story, except it turns out that's for adult rats. If you do this with juvenile rats, they prefer to go down the arm with a shock. And anyone who has had a 2-year-old or a teenager can relate to this. So for the juveniles, they're actually preferring information over utility. So they seem to have this kind of epistemic motivation. I'd rather figure out the nature of this environment that I'm in, even if it's at the cost of utility. And Nim Tottenham just did a beautiful replication of this with 3- and 4-year-old human children with an unpleasant noise. She didn't shock 3-year-olds, but she had them listen to an unpleasant noise, and you see exactly the same. You see exactly the same pattern. But so that fits with the idea about the young being exploratory. But there's a fascinating twist. And the twist is this only happens if the mother is present, both for rats and for humans. So for rats, it's like even if just the smell of the mother is present, then they'll explore the shock. But if it isn't, then they won't. And if the mother has been fear conditioned herself, so that now she's giving signals of fear, they won't explore the shock arm. So the only way that they'll explore the shock arm, and I think this also fits if you think about 2-year-olds and teenagers, is if mom is there and saying, it's okay, chill, right? Everything's fine. You can go on top of the high slot. And what that suggests is that this capacity to be the caregiver, and by the way, it's not just for the humans, it's not just for the rats, it's just moms, but for the humans, it's anybody who's a caregiver, that itself is a kind of intelligence that enables this balance between imitation and innovation to take place. And what I and a bunch of my colleagues have been doing recently is actually trying to articulate. We just have a big project, a big grant from the Templeton Foundation to do this, is to try and work out what's the cognitive science behind this kind of intelligence. What are the kinds of things that you need to do if you're thinking about care? And care is interesting because, again, if you kind of go back to that explore-exploit kind of story, we all know that the reason why there's the explore-exploit tension is because the utilities in exploration are going to be different from the ones in exploitation. But of course, this is even more dramatically true in cases of care, because the nature of care is that you're giving up your own resources for the sake of the person that you're caring for. So it sort of intrinsically contradicts any kind of theory of utility. How could you have a cognitive system that could figure out, okay, what I want to do is not maximize my utilities, but use all my resources to maximize the utilities of this other creature, because this other creature cannot maximize their utilities themselves. And that's what anybody who's caring for anybody else actually has to do. This is a whole other story about what the cognitive science of this looks like. But an obvious function of this care is that it actually is going to enable this kind of exploration. And this is, I guess Anya's not here today. This is work that Anya Damani in my lab, who's been here earlier, has done. Let me just give you a quick first pass. So we just went out and asked people, including children, about a whole lot of different explore-exploit kind of scenarios. And we said, are you more likely to try the unusual food or do the explore kind of option if mom is present or if you're by yourself? And it turns out that both adults and children think that you're more likely to explore when mom is present. And I think this is not intuitive. Like, you might think that the kids would say, well, no, if mom's there, I'm not going to do the dangerous thing that she might object to. But in fact, what they say is if the caregiver's there, that's going to allow people to be more exploratory. But this is just like a very first pass. Okay, now there's another piece of this kind of strategy. So here's the picture. The picture is when you start having caregiving, then you can have this explore-exploit trade-off, because the caregiver is going to provide utility at the time that the cared for agent is doing the exploration. But if you think about that as being a basic human structure, part of evolution, and in fact, humans have a much wider range of caregivers than our close primate relatives. We have fathers who are pair bonded and alloparents, etc. But one of the really distinctive adaptations that we have is that we actually have grandmothers. So we actually have postmenopausal females who are living for 20 years after they're no longer fertile. And they seem to, we have good evidence that they're providing a lot of the care that's actually enabling that long childhood. In forager cultures, the 2- and 3-year-olds' survival really depends on the grandmothers more than just on the mothers and fathers. So one thing they're doing is providing this care, but the other thing that they're doing is that they're the source of this cultural transmission. So this is a picture, as you can see, lurking behind those 3 beautiful children, there's a grandmother. And I always used to use this picture to illustrate grandmothers because it's such a nice picture. But I realized that it actually illustrates something else, which is that what this grandmother is doing is reading a 100-year-old first edition of A.A. Milne's Now We Are 7, Winnie the Pooh, because this grandmother likes to collect first editions of children's books. So what she's doing is literally transmitting 100 years of cultural information to these children. Well, you might think, okay, that's an idiosyncratic grandmother. But it turns out that if you look at other kinds of contexts in which, you see grandmotherhood, so these are orcas, and orcas are the only other primate that we know, not primate, the only other animal that we know of that has postmenopausal grandmothers, you see that exactly what these postmenopausal orca grandmothers do is pass on information about past generations of foraging, which the grandchildren don't actually know about. So the orca grandmothers are serving the same function of passing on cultural information. And there's some beautiful anthropological evidence from Michael Gervin that this is very generally true in forager cultures. So this is a nice example. If you look at, this is almost the last slide. If you look at hunters, hunting is one of these examples, something that people like Boyd and Richardson have looked at a lot. It's a very resource intensive, cognitive intensive ability. People don't get to be really good hunters until they're about 35. But of course, it depends on teaching. That's the reason why it takes you until you're about 35 to become a good hunter. And what Gervin discovered was that when you actually look at the composition of hunting parties, you can see this tension. Again, this will be familiar to anyone who's tried to cook with their 3-year-old grandchild, between the fact that the thing you need to do to actually teach is the opposite of the thing that you need to do to actually be effective. And it turns out that what happens is the 35-year-olds go out by themselves to go hunting. And then the elders, the 50-year-olds, because the men kind of get the postmenopausal thing for free, even though they don't have to worry about menopause, the 50-year-olds who have much more knowledge, even though they don't have the same kind of physical capacity, go out with the 12-year-olds to hunt. They don't bring back nearly as much food, but in the course of doing the hunting, they've actually taught the 12-year-olds how to hunt. Okay, so last slide and last moral is, I think people have mentioned this before about Ted Chiang's beautiful novella, The Life Cycle of Software Objects. And he gives an example of what it would be like if you were raising digients, if you were raising these artificial children. And I think the important point that I want to make is this kind of developmental diversity is a condition for intelligence, so that human intelligence isn't just, here's an agent who's got a particular magic intelligence. It depends on this life history and culture. And let me stop there.
We have time for one question.
No, I'm sorry.
That was my one question.
35 minutes instead of 45 minutes.
So thank you, Alison. This is a great explanation of, human intelligence, the cultural aspects, the early childhood exploration time, the grandparents and all of that. But why do you think that may be the only way to have this intelligence? So let's take the large language models used here is sort of like a straw man. I think what I heard yesterday or the day before yesterday, which I found really interesting, is that the people like Trevor who are working in language are so surprised with the power of the large language models to do what they're doing, even people who had been working in that. So it looks like, I wouldn't say right now they have intelligence or they're agents, but it looks like there's a possibility of things that we haven't thought of or ways of developing this intelligence that may come from looking at artificial general intelligence. So
well, I mean, that's certainly possible. I want to emphasize the reason why those large models are so good is because they're encapsulating thousands of years of human intelligence across
Trevor made that point
across many people. It's not because they're agents who are going out. Now, as I said, I think it's certainly conceivable. And, as I mentioned, we actually know how to create extremely intelligent agents, and it's much more fun than doing coding, right? I mean, we know that there are computational agents out in the world that are capable of doing these things because we know that they exist. The question is, what sort of structure might be necessary in order to produce them? And really, the argument that I'm making here, and this is one of those ones where the theorists would be great to have the theorists around, is for at least humans, who are the one that we know best, this developmental division of labor seems to be really a crucial piece. And there are theoretical reasons, because of these trade-offs between different kinds of capacities, that would be the case. It's not just, okay, this just happens to be humans. If you're thinking about this kind of explore, exploit, transmit recipe for actually being able to be effective in the world, then it seems quite, we kind of have little bits of it. So RL, for example, is trying to resolve that explore exploit tension by doing things like having annealing. And the question is, if you sort of imported that as a general strategy in AI, I think it's extremely plausible that, these are wings and not feathers. These are things that actually are the things that are necessary to be able to do what we can do.
Thank you, Alison.
Thanks, Sherry.